So our last section we're going to take a look at is 4.3, which is on law of cosines. All right. So first thing, I just want to look at this problem. We're going to try to solve it in a little bit. But what would be difficult if you tried to do this with what you know right now? Yeah, none of it. You don't have a full row anywhere. Okay, so for law of sines, you pick two rows and you plug it into the formula. But out of the two rows you pick, there better be only one thing you don't know. You have to know 3 out of 4. Well, if I pick the first 2 rows, I'm missing 2 things. If I pick the last 2 rows, I'm still missing 2 things. And if I pick the first row and the last row, I'm missing 2 things. All right, so no matter how you set up law of sines, this one's not going to work. Let's sketch it and just see what kind of triangle it is. Okay, so we can put A across from alpha, B across from beta, and C across from gamma. Okay, using the 3 letters, A and S, what kind of triangle is this? Amber?
Side angle.
So we got side. Yep, agree with that.
Side angle, side.
Yeah. This time the angle that we know is between the 2 sides. Okay? So this is side angle side. If you go back and look at your notes for law of sines, that's not one of the types I said you could do. So to do that, we've got to use the law of cosines. Okay? Law of cosines is used for 2 types of problems only. This is one. Anybody think of another abbreviation with 3 letters we haven't dealt with yet? We've done angle, side, angle, angle, side, and side, side, angle. One more. Yeah?
Did you say angle, side, side?
I did, but I said it in a nicer way.
Right.
We usually say SSA instead of ASS, but just to be nice. But yeah, it is the same thing. Let's just write them down. So for law of sines, let's make a list. We've got side, side, angle. Okay, that's the one that you got to be careful. Angle, side, angle. Angle, angle, side. Okay, law of cosines. Side, angle, side. And there's one more.
Side, side, side.
Side, side, side. Okay, these are the 5 and the only 5 types of problems you could have on the test. This is the only case where you have to worry about multiple answers. Everything else, it's guaranteed always one answer. Okay, so side, side, side. Okay, on the left is an example of side, angle, side. On the right, side, side, side. So as I give you the law of cosines, it comes in 3 parts. Just like the law of sines, there's 3 fractions. Okay, well, this one's more like 3 equations. Okay, and which equation you use, it just depends on what you're given. So in my formulas, A, B, and C will be sides. Alpha, beta, and gamma, angles. And it starts out like that. Does that remind anybody of anything? Yeah, Pythagorean theorem. C squared equals A squared plus B squared. But we can only use Pythagorean theorem if we have a right triangle. Right, so what we're going to have to do is adjust it. Okay? This is something we have to subtract on the end. Right, so it's 1 side squared equals the sum of the other 2 squared minus twice the product of the other 2, A and B, times the cosine, because it's law of cosines. And it's the cosine of the angle you had at the very beginning, cosine gamma. I'll fix my gamma. Okay, and that's what the law of cosines looks like no matter how we rewrite it. 1 side squared equals the sum of the other 2 minus twice the product of the other 2 times the cosine of the angle across from the side you started with. All right, so let's see if we can figure out what it would look like when it starts with b squared. Okay, same basic structure, all the letters just move around a little bit. All right. Anyone think they can tell me the next two letters that are going to come after b squared here? Jane?
A squared plus C squared.
Yeah, it's one letter, and then use the two you didn't. B squared, A squared plus C squared. Good. Minus 2. Cooper, what two letters would I have here?
A and B.
A, yeah, we had A and B before, yeah. A and C now. AC times the cosine of the angle across from B.
Beta.
Beta. Yep. And that's our second version. And the third one, again, same thing, just rearranging a little bit. Aaron, what would come after my equal sign here?
B squared plus C squared.
Yep, good. B squared plus C squared minus, Amanda, what would come next?
BC.
Yep, minus 2. Look at the two letters you just used right before it. And then cosine of the angle across from the first letter, alpha. Okay, it helps to just kind of learn the general pattern, then you don't have to memorize 3 things. And if you have a problem where they don't label it, you know the general concept. Okay. Right, any questions on that? All right. Okay, so as far as notes, that's really it. That's all you need for law of cosines. Okay, we'll try 3 examples. We'll do one side angle side, one side side side, and we'll try a word problem. All right, example 1. Okay, on the test, first thing you got to figure out is should I use law of sines or law of cosines? Which law would you use here just by looking at the table? Brianna?
Cosine.
Yeah, why cosine?
Because there's not a full row.
Yeah, you don't have a full row. Good. All right, now we got a choice of which law to use. Okay. Keep in mind, every law has every side in it. Okay, every law has an A, B, and C. We're already missing C. So we can't be missing anything else. So which version could I use? First, second, or third with what I have?
First.
Yeah, I'm going to use the first one. Okay, fill in everything you know. C squared we don't know. A squared, B squared, minus 2, AB, cosine, gamma. Okay, that's it. Now we just do it out. Trevor, what's 2 squared? 4 and 3 squared? 9. What do you get when you add them up? 13. Minus 2 times 2? 2 times 2? Brandon? 4 times 3? 12 times cosine 60. All right, what do I do next here? And this is usually where people make a mistake. Eddie?
Did I subtract 12 from 13?
Yep. And that's wrong. Yeah.
Yeah, you want to subtract, you want to add 13 to both sides to cancel it out. Wouldn't you want to do that or no?
Well, our goal is to get C by itself. So
Oh,
since
yeah.
we already have C squared there, I'd leave everything on the right side.
Okay.
But I like your thinking for future problems. We might have to move something to the other side. Yeah. Tyler?
12 times cosine 60.
Yeah, let's do 12 times cosine 60. Okay, if I'll just save us a little time, the cosine of 60 is a half. Okay, if you type it in, that's what you'll get. Okay, so now we get 13 minus 6. Now we subtract. Justin, what's 13 minus 6? 7. So c squared is 7. And Amanda, what's my last step? Just to get rid of that exponent at 2.
I know what you're talking square root.
Yeah, just square root. Square root. And it's the square root of 7. Okay, on the test, I'm going to have you round that off. 2.646. So that's C. Right, now that I've got that, I'm going to sketch it, and I want to see what kind of triangle I have now. So I had 2, 60, that was 3. Now I know that. Okay. Besides side angle side, that's what it was originally. What is it now with this extra piece of information? You could look at it as side, side, side. Or what's one other way you could look at it? You could look at it that way too. Side, side, angle. Okay. The first two, you'd use which law for? Cosine. How about the last one? You could use law of sines to finish this off, but I'm not going to suggest it on this particular case. How come?
You get 2 answers.
Yeah, this is the case where you got to deal with 2 answer, 1 answer, or no answer. So to avoid that, we're not even going to think about it as law of sines. We'll do law of cosines one more time. All right. Now, the way I'm going to do it, I'll find alpha, and then once I have that, I'll just add them up and subtract from 180. Okay. What's the danger in doing it that way? If I find alpha, add it to 60, and subtract from 180. Yeah. If I get alpha wrong, I'm going to get beta wrong automatically. But honestly, if I've got C wrong, at this point everything's going to be wrong because I have to use C to find alpha and beta. All right. So side angle side is the type. If you get one thing wrong, probably going to get both other things wrong. Right? The next type is not like that. You can get each part right or wrong separate, which is nice, but not this one. All right, so let's find alpha. Okay, how does my law of cosines start out to find alpha? How does that one start? Tommy.
What was the question?
How does the version of law of cosines that has alpha in it start out? You can look. Do you have it in your notes? Somebody help him out. Think about which letter alpha goes with. A. So it starts out a squared equals b squared plus c squared. So a squared equals b squared. Just doing it as I go. And c squared, I've got right here, 7. Okay, c squared was equal to 7.
Root of 7 is square root of 7.
C squared was 7. Yeah. C is the square root of 7. Yeah. So I can take 2.646 and square it. But the answer is just 7. Okay. All right, so we got a squared equals b squared plus c squared minus 2, what letters come next?
C, B.
Yeah. We get A, B, and C. Okay, so 2 times B times C. This is where if I got C wrong, the rest is going to come out wrong. lastly, times the cosine of, what are we finding? Alpha. All right, so here, just make sure you follow your order of operations and rules for solving an equation. You can add these two up first, it's okay, because adding these up doesn't affect multiplying these. So that's fine. So 9 plus 7 is 16, minus 6 times 2.646. 15.876. All right, now, what do you think I would do next here? Mhm.
What did you just do the cosine of 15.876 times cosine, or?
Yeah, if we had a number for alpha, yeah, we would do the multiplication. But since we don't have a number for alpha, nothing I can do to simplify that. Because that's a variable.
Divide both sides by 15.
I like the idea of dividing by the 15, just not this step, the next step. But that is a good idea. Anybody have another idea? All right, what if we had an equation like this? 4 equals 16 minus 15x. You have a number equals a number minus another number times something you don't know. Whatever you do here, same thing you do here. Yeah?
Subtract 16 on both sides.
Yes. Subtract 16 from both sides. So this is where Eddie earlier said move something to the other side, and I said I like that idea. Just hang on to it for the next problem. Okay, so if you do that, I'll also do it here. It's going to be negative 12. All right, so now I've got negative 12 equals negative 15.876 cosine alpha. Okay, now Tyler, what would I do to get rid of that negative 15? Yeah, divide by negative 15.876. Just like in the problem up above, you divide by what's in front of the letter. This is usually where most of the mistakes come from, okay, right here. Okay, when I divide, the negatives and the 15.876 cancels. There, the negatives cancel out. Okay, for now, don't worry about this decimal. Okay, don't round this off. Don't even type it in until you're done. Okay, we've seen this kind of problem before, where you've got a variable next to a trig function, and you want to get rid of the trig function. Yeah? Yeah, this time, not inverse sine, but inverse cosine. Okay, and that cancels it out. Okay, so type in inverse cosine of 12 over 15.876, and that's our answer. Okay, so you cannot do this really without a calculator. Gotta have one. 12 divided by 876. So we get 40 point. I guess we could just round it 40.90. Okay, it really rounds up. Okay, and my last step, I'm going to find beta just by adding up and subtracting from 180. 40.9 plus 60. And we get 240. Let me try again. 60. That looks better. 79.10. Yeah.
So when we're doing this on the test, are we rounding it to 3 or 2 decimals?
Yeah, we'll go to 3. Except this one was 40.8999, so it rounded up. Okay. Any question on that? Okay, that's a typical law of sines problem. Okay, on the test, if you got 79.2 for beta, I would take that. Okay, if you got 79.0, that's okay. If you get like 79.8, something's off with your rounding. Okay, way off. If you're going to 3 decimal places, the 10th digit shouldn't be off by that much. Okay? If it's off by 1 or so, that's okay. Same thing here. If you got 40.8, I'd accept that. Okay, and our last type is where we know all 3 sides. Okay, so this is side, side, side. A is 4, B is 3, and C is 6. Now, on the test, I'm not going to do this to you, but the only way you could get a no solution with this kind of problem is if you had the sides listed and 2 of the sides didn't add up to be bigger than the third. That works perfect here. If you add up A and B, it's bigger than C. If you add B and C, it's bigger than A. If you add A and C, it's bigger than B. If I gave you a problem like this, that would be no solution. Okay, I'm not going to do that on the test, but I'm just saying that would be no solution. It'd be one of those triangles where the sides wouldn't meet. You'd have something like this. Sides would be too short. All right, so I know all 3 sides. Which version of the law of cosines should I use? Yeah, any of them. Okay, if you know all 3 sides, you know everything up to the word cosine in every formula. So you can pick any one you want. How many times are we going to have to use law of cosines at a minimum?
2.
At least twice. You've got to find 2 of the angles, and then if you want, add them up and subtract from 180. If you have enough time on the test, you want to do law of cosines 3 times, go for it. That way you could get 1 right, or 2 right, or 3 right. Each part is separate. Okay? When I do it, I'm just going to do it twice. All right, so let's do alpha first. Okay. Anybody think they can give me my whole equation that has cosine alpha in it? If you have to look back, that's fine. Just tell me what I would have to plug in.
A squared equals B squared plus C squared.
Yep, which one are you doing?
Alpha.
Alpha, yeah, go ahead.
A squared equals B squared plus C squared minus 2 BC cosine alpha.
Cosine alpha. Okay, so as she said it, I filled it in. A squared, B squared, C squared, 2 BC cosine alpha. Next step, add 9 and 36. Jezreel, what does 9 and 36 add up to?
45.
45. 2 times 3 is 6. And Emily, 6 times 6? 36. Cosine alpha. Okay, Brandon, my next step here.
You're going to want to subtract 45 from each side.
Good. Okay, subtract 45 from each side. Do not do 45 minus 36. Okay, a lot of people will do something like that on the test. They'll come up to me and they'll say, I'm getting no solution. And I know why, because they're just not subtracting correctly. Bring 45 to the other side. Okay, negative 29. Okay, Kobe, what's my next step?
Move 36.
Yep, and how do we move that? Think about if you had this. When you have multiplication, how do you undo it? Divide. Okay, if you add, you're going to end up with no solution. It's not going to work. Okay, so on the right, that's gone. On the left, that's gone. Okay, last step, get rid of cosine with inverse cosine. So take the inverse cosine of 29 over 36. So we get 36.336. And that's alpha. Okay, so really the law of cosines is that was all the work right there. Okay, you really can shorten it up if you do some of the steps in your head. Okay? There's not as much to write out. Hey, any question on how I found alpha? All right, so why don't, on your own or with someone, try to get beta. Okay, see if you can get beta, and then we'll come back together in a minute. Put it up. Okay, so to solve for beta, it's b squared equals a squared plus c squared. Okay, so I don't have to scroll up and down. Can someone just remind me what was b?
3.
All right, so b squared, what was a?
4.
And c?
6.
Minus twice the product of 4 and 6. Cosine, which angle are we finding?
Beta.
Theta. Okay, so 52.
Minus 48.
Cosine beta.
Minus
Okay.
52.
Yeah, one mistake I saw, people added 52. It's already positive. Make sure you subtract it. And that's going to give me negative
Negative 43.
43. Next step, how do we get rid of negative 48?
Negative 40.
We're going to divide. Divide. Okay, at this step, if you've got a bigger number in the top than the bottom, don't even bother. Just go back. Okay, if you've got a bigger number in the top, it's not going to work. The bigger number has to be in the bottom. Okay, so we got 43 over 48. And what do we have to do to that?
Use the inverse.
Inverse cosine. Okay, and if we do that out, what do we get? 26.384. Okay, now to save time, I'm just going to add them up and subtract from 180. Does anybody have that answer?
On 117.279.
279. Okay. Okay. Again, it's your option. If you want to find law of cosines, do it one more time to find gamma. You can. It's going to take longer, though. Okay. It's up to you. Okay. Any question on that one? All right. So, last one. All right. So this it's going to be a word problem. Not as bad as the one we did yesterday at all. All right, so for this problem, a surveyor is going to measure the distance between two houses. Okay, for the point of this problem, I want you to pretend that there's some obstacle between the two houses. Okay, for some reason, he can't just draw a tape measure. Okay, whether it's a cliff or a river or fire ants, whatever you want to imagine. Okay, he can't measure the distance between the two houses. Okay, but from his position, he can see one house, can see the other house, and he can get the angle between the two houses, okay? And that's 70. He can walk to each house. He can't just walk between them. That's the only problem. So he walks to one house. From where he's standing to one house, it's 50 feet. And then from where he's standing to the other house is 70 feet. So what we want to know is the distance between the two houses. All right, so in my diagram, instead of putting a cliff or a river or poisonous fire ants, I put tree frogs. Okay, so he can't walk between the houses. There's too many tree frogs. Okay, they attack him. It's awful. And I couldn't find a surveyor quickly before the problem, but I could find a trench soldier. Okay, so our trench soldier, he's our surveyor. Okay, just pretend. All right. So first thing we know is the distance from him to each house. Okay, the distance to house A is 50 feet, and the distance to house B, 70 feet. Okay. He was also able to measure the angle between the two houses. That's 70 degrees. Just a coincidence that we have 70 feet and 70 degrees. Okay. And what we want to know is x, the distance between those two houses. Right. So this problem, you know a side, you know an angle, and you know a side. Is that law of sines or cosines? Cosines. Right? And here's where we just have to remember the general idea. One side squared equals the sum of the other two squared. Okay, start with that. So x squared equals what comes next? 50 squared plus 70 squared minus twice the product of the other two sides. So what's going to go in the parentheses here? 50, 70 times the cosine of our angle, which is 70. That's it. So now we just type it in, do it out, and we get our answer. Okay. What's 50 squared? 2,500. That's 4,900. 2 times 50 is 100 times 70. That's 7,000. Okay, I think there's at least one more thing we can do by hand. What's 25 plus 49? 7,400. Okay, now we've reached what we can do without a calculator. Okay. Do I subtract next or multiply?
Subtract 74.
So that's,
From or move to the other side.
well, keep in mind we want to get x by itself. So don't put extra stuff with the x. So my question is, do I do this subtraction or do I do this multiplication first? Yeah. Okay, do the multiplication first. Okay, so we get 7,000. Okay, guys, I need attention up here. Thank you. 7,000 cosine 70. Okay, so we get 2,394. Let's just round it, 0.1. $394.1. Okay. Now subtract that from 7,400. What I can do is just take 7,400, subtract the last answer. 5,005.9. So is that the distance between the houses? So yeah, square rooted. So the distance is about 70.8 feet. Okay, any questions on that? Okay, so now you've seen everything that's going to be on the test. Okay, tomorrow we'll review and go over the homework. Okay, so homework, page 274. 9, 11, 13, 17, 25, 27.